Okay, I believe that we're live, and I'm here with Ryan Fortner, and we're going to have a little discussion on the haplogroups, and we both can share, and we'll both be sharing our findings, as you say, and everybody already knows pretty much of what I have to say already, so at least everybody on my channel. So I'm going to let Ryan Fortner explain a little bit of what he believes that how the haplogroups fit together, and so yeah, you can maybe introduce yourself, Ryan, and share your thoughts.
Sure. So I don't have any formal training in any of this stuff, but I've been studying Christian evidences for a long time. I taught it to middle schoolers and high schoolers for 3 years in a private school, and the last couple of years I've looked at the haplogroups quite a few times. It was a funny thing because there's a lot of stir right now about Nathaniel Jeanson's book, Traced. And just 2 years ago, just before he started researching all this stuff, or maybe around the time he was already researching it, I found out about it. I started trying to figure out who was who, and I, I I reached a lot of the same conclusions as you did. It was really funny, but I realized, well, some of it doesn't seem to work genetically, and then I I kept changing my mind about how I thought things had happened, and then I found out about Jeanson's work, and he had this video series. I think it was like 24 videos that he put out 2 years ago, and um, based on that, he said he was going to eventually write a book, and he now has. And I was looking for criticism of that book because there were some things in it that I didn't think made sense, but I was looking for criticism of it, and that's how I found one of Jungle Jargon's videos, and started commenting, and here we are. Is there anything in particular? Where do you want me to start explaining?
Yeah, maybe we can start explaining the different SNPs, they call them SNPs, and how they make the divisions between the groups, and like you were explaining to me a little bit just a little while ago, and because it's basically the same thing, the same way that I believe it is, except that we might not have all of the descendants of, all of the grandsons of Noah included. There might be some missing,
Okay.
but you can go ahead and share again.
Yeah. So I think I know a good direction to go in for that. Um, Let me, because I was telling you about this new way I thought of for looking at it. Let me kind of try to draw this. I don't know if this is going to work. This is my first attempt at drawing this, but so can you see my screen?
Okay, let me try again.
Let's make sure it's working.
Okay, there's.
All right. So the way that they define all these haplogroups, it's a nested pattern. It's not quite like you have Noah and then all of a sudden, boom, there are the 16 grandsons. Here you've got 16 haplogroups. They're defined separately. They just appear. It doesn't really happen like that. And I've heard a lot of people actually thinking that it does. It seems to be a pretty common idea because of the way they're named. Because and there aren't 16 letters named. I don't think. I haven't. It's A through T, however many letters that is. Maybe it is 16, but
Well, yeah, there's almost, for all intents and purposes, there's 7 sons of Japheth. I thought there was 5 sons of Shem, but there might be 4 sons of Shem.
that are left.
And then there's 3 trees of Ham, which is North Africa, Mitzrayim, and Canaan. And then Cush would be the A, B, C, D, and whatever else is included.
Okay. Yeah. So the way that they define these haplogroups, the only evidence we have to work with is whatever genetic variants exist in the Y chromosomes of living men or in fossil sequences when those are
Right.
available.
That was a
And,
question I had. That was a question I had is how do they don't have the genome of Q and R. I mean,
exactly.
Madai and Gomer, they don't have their genome, so how do they know what genome they had?
Okay, so here's where I'm going to actually start drawing. So basically, you start from think about how this progressed in real history, how people discovered this stuff. So you start with not knowing anything about DNA. DNA is discovered, chromosomes are discovered. They figure out that the Y chromosome doesn't recombine with any other chromosome, meaning it's a straight shot back to Noah, back to Adam. So it never combines with the female DNA. So it just forms a family tree. On a normal family tree that includes all your DNA, you're going to be crossing lines everywhere. You're not going to be able to trace it back very far. So that's the great thing about the Y chromosome. It's a straight shot. It never deviates. But it also leaves a trail because every generation there are mutations. There's a tiny little change, and it's a single nucleotide polymorphism, SNP. Apparently, they pronounce it SNP a lot of times. So you can look at. I keep saying I'm going to draw this. You can sequence the DNA from one person's Y chromosome, and you can sequence the DNA from a second one and compare the differences. And you can say, well, okay, let's just say, for sake of argument, they're brothers, and there's only 3 mutations different. So you can say, let's draw a circle over here. This person, inside this circle, there's this SNP that if you have this, there are 3 mutations in this case, we're just saying. So if you have these are the defining SNPs for this person. And a circle over here, they do not overlap. These circles are never going to overlap. No matter how many circles you draw, unless 2 people independently get the same mutation, you're never going to have an overlap. And the Y chromosome has a lot of DNA letters in it, so it's very unlikely that someone's going to get the same exact mutation as someone else. But let's say this guy has a son. Well, he's going to pass on probably about 3 mutations to his son. There's his son. Let's say he has a second son. There's his other son. And over here, we can give this guy 2 sons as well. So what's going to happen is we can call each of these circles by some name so we can remember what they are. We could say this one is A, this big circle is A, and this big circle is B. And then we could say, well, hang on. We could say this is going to be A1, and this one's going to be A2. And if you didn't know anything about these guys and who they were, how they were related, you could still figure this out just by sequencing their DNA. So there's B1 and B2. You could figure out how they were related because it's a Venn diagram. You can look at A1 and you can say, okay, this guy has the A mutations plus some new ones. B1, this guy doesn't have the A mutations. He does have the B mutations plus some more. B2 also has the B mutations, but he doesn't have the B1 mutations. He has the B mutations, and then he has the B2 mutations on top of that. And you can construct a tree from this. You can start back here and you can say, here's A, here's B, and guess what? We can keep doing this. And you can construct a tree that goes all the way back to Noah. So you see where I'm going with this. And it's all based on, you just sequence the DNA from everyone alive today, and as many as you can get, and then compare the differences, and they're going to line up in these Venn diagrams or these trees. So you're not going to have someone who has the defining SNP of the A group who also has the defining SNP of the B1 group. Doesn't happen. These lines never cross. You're going to have someone who's in the A group, and they're going to either be A1 or A2. And then, because we haven't sequenced the DNA of every man alive, you might have something funny happen. Oh, here's someone who's just, this person is just A. They're not A1, they're not A2. They're just A. Are they the ancestor? No, that can't be it. You should really call it A3. Or maybe it's A1A and A1B. We have to make smaller and smaller circles. If he's got the A1 SNP, if he's got that defining mutation, then you have to put him in this bubble. But if this guy just has the A SNP and he doesn't have this and he doesn't have this, then you got to assume there's another bubble here, or rather, it's another line coming off the family tree.
It's another line coming off the A tree, right?
Yeah. So in the actual, let me see if I can share a different window now. I'm going to show you a real example. Let me see.
You got to share again because you unshared.
Yeah. I'm still getting the hang of this. Okay. Yeah. Can you see this one now?
Okay.
Okay. So this is actually the tree for the K haplogroup, and this is the Wikipedia article. I know Wikipedia is not a scholarly source or anything, but this stuff seems to be pretty well established. Some of the naming conventions aren't the same for every source. They have their sources listed here, and you can go to the Wikipedia article for this group and you can look at the original sources. I just find Wikipedia is a really convenient place to find family trees.
Yeah. It should be pretty good, I think.
Yeah. And this, it's empirical. If you go to Wikipedia and ask, what's the age of the Earth, that's not nearly as simple. There's a lot of factors. There's a lot of bias involved. Something like this, it's just empirical. It's just, let's just count up all the SNPs in this guy's DNA, compare it to that guy. It's if you have the technology to do it, it's actually kind of simple. So they have these confusing names. I don't know what that's about. This is Haplogroup K, but you can see here, this is the same thing. K is K-M9, whatever that is. So there's K, and then remember, you're going to, whatever the defining SNP for K is, you're going to have all the descendants of K are going to be, K1, K2. So look at this. The direct descendants are K2, formerly something else. They've got a lot of different names. They keep changing the names. So there's K2 and there's K1. And K1 is also known as LT. So let's look at this family tree down here. I drew mine top to bottom. This one is drawn left to right, but you can see what they're doing here. So you got LT, which is K1. So right here, this is half the family tree.
But that LT is just L and T.
Right.
It looks to me, right?
It is, but because it came out of the, well, hang on. No, I can't switch where I'm sharing. Oh well. So if we drew bubbles for this Venn diagram, we would draw the big K bubble, and then if you sequenced the DNA of someone from L or T, what you'd get is they have the defining SNP of K, and then they have the defining SNP of LT, also known as K1. And then they also have the defining SNP of L, if they're in haplogroup L, or of T if they're in haplogroup T. It's going to be one or the other.
Okay.
Yeah.
Can you explain the difference between the evolutionary perspective with the rooting of the tree and our perspective of the odd person out is the way I look at it?
Yes. So real quick, in K, half of it is LT. The other half is all of this. So this is K2. And what's really interesting, I'm going to move on, but what's really interesting is you've got K2A and you've got K2B, and these both expanded. They're all over the place. You get N, O, P, Q, R, S. You get all these M. All these others are coming out of here. And then you got Look at this. It looks like K2 had 5 sons. K2A, K2B, and then K2C, K2D, K2E. You don't hear about these very much, but these they didn't give these special letter names. They're still parts of K, but it's arbitrary. They could call it whatever they wanted. But look at this.
So K
These
has 5 sons. So K has 5 sons.
Oh, sorry. K2 has 5 sons that we know
K2.
of. Yeah. And actually, probably more, because look at this. This is so confusing. This got me for the longest time. So you've got K2A through K2E. You've also just got K2, and then there's an asterisk after it. This is so weird. So what does this mean? And turns out, I don't think it says it here, but elsewhere it explains, there's another article that explains how when they just say K2 in a living person today, what they mean is it's not A, B, C, D, or E. It's just some other branch of K2, and they haven't classified it. So K2 unclassified is pretty common among the Aborigines of Australia and some other places too in that area.
Okay, but they're still all K, right?
Right. And I mean, we could say all these are K. L, T, Q, R, M, S, it's all K.
Oh, yeah.
But they just didn't give this one a special name. They haven't even classified this to the third symbol yet, because you can see the other descendants of K2, you got K2A. This one's just called K2 with an asterisk because they haven't classified the branches. There are 5 defined branches. They've defined the SNPs of what is K2E. It's a very rare lineage, but they've defined what it is.
So the M and the S are basically, of course they're K, but I mean, wouldn't they be like a specific branch of a K? Or
yeah,
I think because I have K assigned as tubal, because there's like you were telling me before that 8% of Italy is K2.
So that's weird. I don't know why they wrote it like that, because they've got R1B in Italy, and then they've got, if you look at that image that you had shown there for Italy, they've got R1B, and they've also got a specific sublineage of R1B. I forget its name. And then they've got K2, which is bigger. You know, K2 includes
everybody.
It includes R1B, but it includes a lot of other stuff. So I thought that was kind of a strange way to write it. Are they saying there could be some N or some O or something else? What? Because on here you can see no one is talking about K2 being found in Italy. It's Oceania, if it's unclassified K2. So
yeah,
I don't know.
That would be interesting, because
Yeah.
Tubal did settle in Italy, because
Sure.
And of course he went to Asia too, as the descendants.
Yeah, and you can trace Tubal's name, Tbilisi in Georgia, Tobolsk in Russia. So that's, yeah.
Okay.
Whether there's a genetic signature or not, there's evidence of that. You wanted me to talk about the root.
Yeah.
Let me see. Am I still sharing? Yes. All right. So I can share a different thing. Yeah, okay. So basically this thing with the root has to do with, the way you put it was, who's the odd one out. This is an unrooted tree, if you can see this. This is kind of like the stuff you've been showing. Well, now you showed some like this, but you also showed some that was clearly made by evolutionists because it showed the root in A. That's what they think. This branch is so much longer than the others. They think, well, there must be a constant mutation rate, because as we know, evolutionists love constant rates of everything, the uniformitarian. So the rate must be uniform, which means this extends deeper into the past. It doesn't extend into the future, so it must extend deeper into the past. We started back here. The San Bushmen of South Africa and stuff like that. This is the oldest people group. And then we come up here and it branches out. You get B on one side, and then you get everyone else on the other side. And you keep branching like this, and it's going this direction. This is downstream, is going to the left here, and then it goes all different directions.
Oh, you're not sharing. Oh, wait a minute. Sorry about that. I gotta put you sharing.
Oh, is that not visible?
Okay, now you can.
Okay.
Sorry about that. I wasn't paying.
Yeah, so you can see now what I was talking about. A is this super long branch. And again, their naming system is very strange. They probably discovered A1 first, and they discovered another A branch, and they called it A0 because they think it's older. Why is it
Right,
older? Because it's longer.
right. That's what I joke about all the time. They found an A, then they found an A0,
Yeah.
then they found an A00,
Yeah.
A00.
And I think it's because they have to give it a lower number because they think it's older.
Yeah,
I guess because the longest branch
which
must be the oldest if you're
but it
committed
makes
to
no
counting
sense.
traits.
That makes no sense because there is no lineage that's any older than any other.
Well, the idea here is that it's so confusing, but A is still called A because that's just what they call it. The names are arbitrary, but supposedly the oldest, and now I feel like I need to look at an evolution based tree, and I don't have any of those saved, but I could probably find one pretty easily. But now I can do it from here. So basic idea is you start with some ancestor of A, and it branches off into the modern A and into something that gives rise to this side over here. So obviously this side multiplied a lot faster. It's kind of strange how much this side multiplied more than this side, but that's what they say happened. See, so you keep going to the left here. Going to the left is downstream, meaning forward in time.
Forward in time, which makes no sense. Yeah,
So some direction here has to be forward in time,
because
but we
the
don't
thing
know.
is, what I keep trying to explain to them, we did not our ancestry does not come from A or A1 or B. Our ancestry does not come from any of those. Our ancestry is totally separate from them.
Well, the question is, well, okay, so evolutionists would agree with you in one sense, and that is that everyone alive today, we're all basically cousins. So the San Bushmen that have haplogroup A, those are not our great grandparents; those are our cousins, because
Yeah,
they're the same generation as us, give or take a few. But and they know that the evolutionists know that. But what they're saying is someone who had what they're and this is where the mind games start. But they call the ancestral haplogroup that gave rise to A and the rest. They call it A or a type of A. They call it A000 or whatever. So
yeah,
that's supposedly the ancestral because this is where they put the root. See the tiny
yeah,
arrow?
yeah.
I didn't realize it when I was looking at this a second ago, but yeah, this is where they put the root. So they say, okay, you go one direction and you get branching into A1, branching into A0,
Okay, I see.
stuff like that. Yeah. So the other direction is, and these angles are confusing too, but you go this direction on this line and then it branches. And
Right,
at this point, you're still going forward in time, but one sun goes this way to B, the other
right,
sun goes over
right.
here.
I see.
And so this son, this great grandson of whoever it was that gave rise to B, also gave rise to all these guys.
C and D. But
Yeah, so
we know C is the son of Cush, though.
they're gonna ignore that. So
And yeah,
you got from here. Look where it goes. You've got one sun that goes this way, one sun that goes this way, and one sun that goes this way. So you can see the one that goes this way, his family splits again into D. D goes this way, and E. Well, E keeps splitting into E is a pretty big group, and so it gets these other names that are put on here. There's a D1 and a D2
well,
as well.
that's
It's
the
just they're
thing.
small groups and it's not showing up here. What?
That's the thing. The E is a big group because they started out way out in the bush and they didn't even consider the main population. So when they come to the main populations, they're just all E3s basically.
Well, I think E is a big group because look at what's happening here. This again, this image is not evolution or creation based. This is just the facts. The idea that you have to start over here, that is an evolutionary idea. Where you start is opinion.
Yeah.
But they start back here. And when you get, so I think pretty much everyone agrees, everyone I've ever heard of agrees, when you're at this point right here, you're going downstream right here. You're going forward in time. So you get to right here, and one sun goes up to D, other sun goes over here to E. Okay, there's one line right here. This is how many SNPs? I don't know. Quite a few. This is probably several generations moving forward here. I say that because this length right here can't be a quarter of a generation or a fifth of a generation. It has to be some multiple of a generation. It has to be a whole number of generations. This line is longer. Therefore, this must be multiple generations, unless something really weird is going on with the mutation rate. So in other words, one son of whoever's back here, one son has a great-great-grandson who has two sons, and so on and so on. So this, all these E people, they're attached on all these lines because they are in the same bubble in the Venn diagram. They have the defining SNP for E. They had an ancestor that had haplogroup E, just E. And he had a great-great-great-grandson who had E2 and another one that had E1, and you get the idea.
Again, it could be the odd one out, right?
What do you mean?
The odd one out could be Kush. And
yeah. So I think at this point, you, me, and Jeanson all put the root at the same place. We don't go over here. We go right here in the middle of it. Doesn't that make more sense? That's where we all put it right now. Creationists are in pretty good agreement about where Noah was, regardless of which sun is
with that little space. Remember that little space you showed me right in the middle?
In between.
Yeah, that little space right in between Shem and Japheth.
Yeah, right here.
Yeah.
Yeah. And what's interesting is, hang on, let me see. Let me get my bearings. Okay. So this line right here is IJ, and that's a few generations before I and J split. But what it looks like is you've got, man, this is blurry. You've got this little gap right here between IJ and what's the next one? H.
H to me, I think is pretty sure is Elam.
That was my first thought 2 years ago when I started doing this. And then I found out about this little gap, and I'm like, well, this is downstream. Meaning whatever SNP is not here, but is here, guess what? That SNP is everywhere downstream from this. It's that SNP, you know? So if you're starting, if Noah's right here, okay, IJ goes this way, K through T goes this way, and then A through H goes this way. And it doesn't look like FGH can be part of IJ, can't be from the same son of Noah, because you've got this little gap right here. There's some SNP that defines this difference, and it's also found in everyone up here, A through E.
Well, I mean, except for the way the diagram is set up, because it's set up backwards from where the root.
Well, we can call the root anything we want, because this diagram isn't set up like a family tree. It's just set up as a big. It's just connecting the dots. It's not telling us a direction.
Because all those F, G, H, I, J, they all have the same SNPs, don't they?
Well, it doesn't look like it, because if you go down here, IJ is here, and there's a little gap right here. I bet I can find a better picture of that.
But they would have SNPs of their own, though. That's the thing.
Oh, sure.
So that's what, because they're all designated as F. They're all designated as F and K, but I mean not K but F. So they all have the SNPs of F, but then they have their own SNPs on down the line.
Yeah, but what I'm thinking is when the evolutionists say these SNPs define F and everything F through T, everything has that, who's the odd one out? Really, maybe the defining SNP of F is actually from Noah, and everyone has that. And what we're really dealing with is upstream is actually downstream when it
Right.
comes to Ham. So, in other words, um, there's some defining SNP that defines F, G, H, as well as A through E. That's what it seems like.
Because the way I thought they were saying is that you know F comes first, and then it's G and H.
That's what they think, but it depends on which direction is downstream.
Yeah, but I mean, as far as the SNPs are concerned, it'd be because if everybody has the F SNPs, then there's the separation of the G and the H, and the I and the J, right?
Um, well, when you say the F SNP, it's this is where it gets so weird because I think you said before in one of the comments on your video where we were talking, we don't have the original sequence. We don't have the Noah sequence, so we don't really know when we say, okay, this SNP defines everything in that direction. Well, maybe what we're really dealing with is the absence of that SNP actually defines everything in that direction, because you don't know what a mutation looks like when you look at the genetics. We can't
Yeah,
look at that and say, oh, this gene is a mutated gene. We don't know that. Instead,
yeah,
all we can do is we can say, well, this DNA letter is one thing for this person and it's a different thing for that person. So evolutionists, when they assume that we all started out in something like haplogroup A, um, then that assumption makes a mess of all their observations. They're confusing their own interpretation with the facts. That's a common
yeah.
mistake. But um, yeah, basically, what it looks like is F is currently defined
Oh, you got to
as
share.
how it's.
You got to share again.
Oh no, I wasn't showing anything on screen.
Okay.
It looks like what they're saying right now is F is currently defined as it's defined by how it's different than C, because you've got A, B, D, E off to one side, and then you've got a split between C and F. And so they're defining F in terms of how it's different from C. And there's this big gap actually between the two. And that gap, if you were gonna somehow make all of F through T Shem and Japheth, and Ham was just A through E, you'd have to figure out how to get Ham over there, because you saw that the size of that gap between F and C. A, B, C, D,
Yeah.
E is all.
Well,
It's
is
so
that gap? That gap is the number of mutations, right? Or the
yeah,
genetic distance?
yeah.
Genetic.
So it's just a question of how do you leap over that in one generation, and maybe you can. I was actually just talking to Rob Carter from Creation Ministries International, who apparently Jeanson consulted him a lot on the book, which is interesting because they don't seem to agree on certain things. Or Jeanson is kind of leaving things out. His book actually seemed like he simplified things quite a bit. But Dr. Carter said, and I can actually post the link to the article. I was just talking to him in the comments on the article he wrote, but he said basically Jeanson's timeline. Let me share that.
Okay.
let me show you what was said. Let's see. Okay. So, where was that? No, hang on. I'm sharing the wrong thing. Let me find it real quick. But he was basically saying the timeline doesn't exactly work. It was kind of the whole point of Jeanson's book, but it kind of doesn't work. Is basically what he said. I don't want to misquote him though. I want you to see it in his
Yeah,
words.
right. Well,
So
I don't think it works at all, but
it was real exciting, but it's like it has some issues.
okay,
All right, can you see the comments here?
okay, it's shared. Yeah,
All right, so I wrote in 3 times actually. Um, Here it is. So I said it seems like the conclusions in Jeanson's book require ancient DNA to be ignored. And I gave an example from R1b, because if you look at the number of mutations or SNPs difference from where Noah ought to be down through the R haplogroup, R doesn't even exist for a very long time. R and Q are just a single line for a long time, and finally the two split. So many generations later, R and Q split from each other. R1b, well, that's even narrower. That takes forever to actually get to R1b. So Jeanson said, well, that must have happened in the AD era. So this is post-Roman that R1b even gets into Europe. Well, there are ancient Roman skeletons from the BC era that have R1b. And I've talked to a guy who has R1b. He and his family have figured out their mutation rate is too slow for the creation timeline. It's also too fast for the evolution timeline, so it's kind of strange. But
yeah. I think the R1B. I had some information from this Brazilian guy. He made a video. He said the Ripfath went to Southern Europe, so that's why I named R1B Ripfath.
well, R1b is just the most common one in Western Europe, and of course they tend to shift around geographically over time. But
But it's totally separate from R1A, which is Ashkenaz, right?
totally separate. I mean, they became different lineages at some point, but they were the same for what looks like a very long time, because they share a ton of SNPs that are not found in some other haplogroup, like well, even Q. Q is the closest one to R, but you could go out farther and in haplogroup O, one of those, R has
Yeah,
a bunch of SNPs that those don't have. So how did R1b, R1a, how'd they all get the same ones unless they were one family line for many generations? But Carter here says Jeanson used the molecular clock concept as a simplifying assumption in his model. And this is important. This does not make it wrong per se, but it does qualify his conclusions. So he's pointing out several ways that we could change the mutation rate. It could vary with time. That makes it kind of problematic if you want to turn the mutations into a timeline. He's appealing to patriarchal drive. He wrote an article about that a while back, and that's basically just where if a father lives a really long time before he has a son, his cells are going to copy themselves many times. They're going to make mistakes. He's going to be full of mutations. Each of the cells in his body are going to have a bunch of different mutations. You never know what he's going to pass on to his sons. So you could make a huge leap forward in a single generation. But
yeah.
what you're probably not going to have is you're not going to have all the cells in his body got the same mutations, and he then passed on all the same mutations to 2 of his sons, but not the other one. That would be really weird. So,
Well, isn't it true in the line of Japheth? You have the N and the O, and you have the R and the Q that are basically the same, right?
yeah, I can show you something on that in just a minute. I just wanted to let me get to the final thing that Carter's final response to me. No, not the last one. That's the last one. Hang on. Which one was I looking for? I guess I already showed it. I just didn't read the whole thing. You can see it there, though. And this is creation.com/family tree for all humanity. If you wanted to read the article, it's not really about Jeanson's work, but several people were talking about it in the comments just because it's making waves right now. But yeah, you can see from this that the family tree thing does not necessarily work. But let me show
Well,
now.
do they have all the information of all the S&Ps, or is
I
it
don't
just
know.
one here and there, or a couple of them so
That's what
far?
I'd like to know. So here's the big family tree on the left. Here's a simplified version of the root on the right.
Wait, let me try again.
Oh,
Okay, go ahead. Yeah,
okay.
go ahead.
So the page, this is from Jeanson's book, and I'm not sharing anything I'm not supposed to share because he makes videos and he showed this exact picture online before, free for everyone to see. So this should be just fine because it's already public. But if Noah is back here, look at this. We got 3 lines. We got one that you have 16 SNPs right here that lead down to this. You got 44 SNPs right here that lead down to this. You got 7 that lead down to this. And
Yeah.
what's interesting is, I know that sounds like it's super well defined, but Jeanson himself said, I wonder if these are going to go away. He said, I wonder if we're going to find out actually there's not a defining SNP for going to the right is downstream. There's not a defining SNP for G, F, A, B, C, D, E. Actually, they have different ones. He's saying, I wonder if we're going to eventually see that A, B, C, D, E is one son of Ham, F is another son of Ham, G is another, and then H is another. And Ham had 4 sons. That's right? Shem had 5.
Yeah, well, yes, Ham had. I mean, Cush had a lot of sons.
Sure. Which, if this is Cush, there you go.
Yeah.
But Jeanson actually said, I wonder if this is actually incorrect. I was surprised that he said that, but there may be some things that haven't been studied enough. That's what that tells me. And then this one, IJ, this is the one. It would kind of make sense if this was Shem. He's thinking Japheth. And then of course you got up here 16 SNPs. Could you do that in a single generation? Yeah, you could if Dr. Carter is right about patriarchal drive, meaning this is Noah to Japheth. If all these guys are from Japheth, so did Noah pass on 16 mutations to Japheth? Typically today it's about 3 mutations in a generation, but Noah's 500 years old. Now we do know that Ham was the youngest son. The Bible specifically says that in chapter 9, Genesis chapter 9. Ham was the youngest son. So why is it that Ham only has 7? Noah passed
But
7 mutations to Ham.
but would they necessarily have all the mutations right away in all of the descendants? I mean, they could like share the same information for a while and then have mutations on down the line, because we don't have the original DNA.
Right. But remember the Venn diagram way of looking at it. So everyone in H, G, F, A, B, C, D, E, they all have these 7 in common. That's why this line is what it is, because everyone here has these particular SNPs in common, and everyone out here doesn't have them. So no, we
Yeah.
don't have Ham's Y chromosome specifically. We can't dig up Ham's bones and find that, but we do know that all these guys have 7 things in their Y chromosome that are unique to them, and these guys don't have them. Evolutionists are going to say, oh well, these are the originals. These guys have the original, and these guys are all the odd ones out. And we're going to say no, it's the other way around. But I mean, if you're going to say FGH actually go with Shem, then what you got to do is you got to explain, well, how is it that Shem gets these 44 and then
Well, that's the
These
thing. That's the thing. It's not
seven.
Shem. It's not. It's Abraham.
Okay, okay, I got you. I forgot you were doing that. Okay, so this is one son of Shem right here, and
Yeah,
these
yeah.
are the others. Gotcha. The question is though, why did Shem pass on 7 SNPs to these sons that just happen to look like the 7 SNPs that Ham passed on to his? Because
Uh,
yeah, that's kind of weird. FGH are over here because their father, whoever that was, passed on SNPs to these 7 SNPs that were also passed on to these guys. Up here, these guys don't have them.
they're, they're also passed. The same snips were passed on to A, B, C, D, and E.
Yeah, so
No,
um,
but it's switched around, isn't it? Isn't it switched around the direction?
the lines are
Yeah.
connected in all the same places, but yeah, the direction is different. So the question is just where to put the root. And Jensen puts the root in the same place that we do at this point. He's come around, but the evolutionists are going to place the root way down this line somewhere, and they're going to say everything over here is going downstream. But the fact
Yeah,
is,
but
there is
that was what was confusing because I'm thinking it's downstream.
yeah. But the fact is that there are these 7 SNPs, these 7 little things in the Y chromosome that it's the same for these guys and it's different for these guys.
It's only those snips are only in that category.
Yeah. So I think
In
I have.
other words, those 7 snips are different than the 44 snips, right?
Oh yeah, and I think I have a clearer way to say it now. If you look at so this is important when you're looking at a family tree version of this versus just a big web like I showed before. In this drawing, the only lines that actually show DNA
Wait a minute.
differences are the horizontal lines.
Wait a minute. If it's Ham that's the odd one out, wouldn't it be going downstream from there?
So downstream is always to the right in this drawing.
But what I'm saying, Ham is the odd one out.
They're all three the odd one out because they're not like Noah. That's how I would look at it.
They're not like Arpachad, but they have their own.
Yeah, but why is it the same as Ham?
The same. They'll be the same. Are they the same snips as Ham?
Yeah. So what I was thinking is a clearer way to say this would be in this kind of drawing, the only lines that have anything to do with DNA difference are horizontal lines. The vertical lines are just there to separate everything to make it clear what's what. The vertical distance means absolutely nothing in this whole thing.
Yeah.
The horizontal difference is the DNA differences, and here Jensen actually has these labeled with the number of SNPs, how different they are. I think that's a really helpful chart. I've looked at this so many times now, but
Yeah.
um, if this has all been sequenced correctly, then what we've got is you've got your starting point. This line, this vertical line, is a point, and it's your starting point. And so from the Noah point, you go 44 unique
But
SNPs
still,
here.
we got a problem. Is it?
Yep.
You mean to tell me that there are no descendants of Assyrians or a
Jensen
descendants of?
specifically says that. He says, we still haven't found the Y chromosome from the Assyrians yet, so we need more
Or
people to get their DNA sequence to see if
but
it's still out there.
what about Elamites? Elamites are
Well,
in the all over India.
yeah, they ought to be. And Jensen says,
That's the only thing. I think history trumps these things here because I
so
mean
Jensen,
how because in Europe you have ancient DNA which is G and C, which
yeah.
would be the Assyrians because the Bible ties Assyrians with Nimrod together.
Okay, so let me say one more thing about this, and then I want to hear more about that. First, the way that I would look at this is if this vertical line is a point, and that is Noah, then what we know is everyone over here, there are 7 places in the Y chromosome where everyone down here, they have it one way, and everyone up here, they have it a different way. So evolutionists are going to say this is the original. We're going to say this is the original. But what we know is there are 7 places where A, B, C, D, E, F, G, H has it one way, and I through T, they all have it another way. So it makes sense that FGH goes with A, B, C, D, E.
Yeah, I can see that,
Yeah.
but it doesn't make sense historically, though. That's
No,
the
it
thing.
doesn't entirely. So in the same way, Jeanson thinks T is the Jews, which is a little nuts because a very, very small percentage of Jews have T. A bunch of non-Jews also have T. But he did show that when you look at a given country and you look at what's the percentage in this country of T, now what's the percentage of the Jews in this country who have T? It's usually a little higher in the Jews in that country. And I'm thinking, well, okay, that doesn't prove that's the original, but it does show that probably whoever T is, they mixed it with the Jews, and there's a slightly higher T content in Jews today. Doesn't mean it's the original haplogroup of Abraham. Doesn't mean that.
Right. But the thing is that if the T is Javan, the Javan Sea people would be the Javan Sea people of the Phoenicians, which
mixed in with the Jews.
Mixed in with the Jews, yeah.
There you go. Yeah, and really the only reason Jeanson is doing that is he's saying the timeline matches up. But like I told Carter, if the timeline thing doesn't really work, Jeanson's identification of the Jews with L and T falls apart, and we don't know Shem from Japheth anymore. So his whole thing is his whole identification thing is built on nothing.
Yeah.
But I think he's done a lot of good work in genetics. It's just he's not a historian. So tell me about this connection between Nimrod and Asher.
Okay, I'll go ahead and do. Oh, I don't know if I have that diagram, but I'll go ahead and try this again. It's sharing right now. Okay, so let me go here. I guess we'll start out over here, and see the gypsies are G, and the gypsies are known to be a part of the Jewish people. I mean, where's the gypsies? Oh, over here. The gypsies they have H, like 40% H and 20% J2.
And they came from India, right?
Well, yeah, they came from the Middle East somewhere. But the H is in India too. But specifically the gypsies, they have about 15, 20% J2 in their population. So it agrees with their tradition of being with the Jewish people, which is J2. But of course, here's the other H is right here, the Dravidians, because they're known as Elamo Dravidian.
Yeah, and I believe linguists don't necessarily agree yet that Elamite and Dravidian are related languages, but I'm pretty suspicious. I actually am wondering if Dravidian is a mix of Elamite and Sumerian or something crazy like that, because I've heard Sumerian suggested as a link to Dravidian too.
Because since L is Japheth, then the H would have to be the Elamite. Is one thing. Now, I wish I could find the ancient DNA map. If I can look it up. I don't know. For the G in Europe, because there was a map that showed ancient DNA in Europe was G and C. And
I've heard that there was some early forms of K in there too, but I think it was K2A that they found, and K2A is the same as the base of NO.
Yeah, maybe I can find it. I don't know. Let me see if I can find the map here. Um, what's this? Okay, let me just go. Let me see. Ancient. Why?
You know, it's funny because when I was first doing this, before I understood anything about how they were genetically connected, I thought it looks like G and C kind of correlate to where Tubal went, and you're actually you're connecting K to Tubal, which is interesting.
Yeah, one of these maps here.
Because
Sure
all of
which
those
one.
were early on in Europe, it seems like.
Yeah, but you got to show the DNA. Let's see. It's got to show the DNA. Where's DNA? I have to. Let me change this. Y DNA. Here it is. I got, or it might be. No, this is one of them, but there's another one.
I think I've got something like this actually. Oh, okay, I see.
Is that showing?
Yeah, I see it.
It's showing. Hold on. Let me save it here. And then I'll go back here.
You know what's funny is the branch of C that was in Europe matches up with the southern branch of C today, like Australians and stuff like that, the Pacific. It does not. It's not the same as the one that's in Siberia or the Americas. So that's kind of funny. Not sure what happened
Okay,
historically.
wait. How do you refresh? Refresh. Okay. See if I can see it here. Is it here? Is it here? Oh, wow.
Hmm.
I don't know where it's
Oh
saved
wait,
to.
was that it on the right down there, all the way to the right?
Oh yeah, this one here. Yeah.
There we go.
Okay, so it is show. What does it show? No, this is actually, yeah, it does show C H
Okay.
C1 A2.
And I believe C1 is in the Pacific in Australia rather than Siberia, if I'm correct.
C1 is only found in Europe, pretty much.
Let me see. Hang on.
So there's C and but I don't see the G here on this map. I don't see the G, but the other map had G and C.
I've definitely seen it before. I know that there's a long history of G in Europe.
Yeah, it had G and C together. That's why it wasn't this map, but this map does have C1, which was strange to me in the beginning. I was trying to figure out how C got in Europe. Um,
All right, so I'm looking at the Wikipedia article for C1, and it's saying, let's see, of the two primary branches, C1b is common in parts of Oceania and Asia. The other primary branch, C1a, is extremely rare worldwide and has been found mainly amongst individuals native to Japan or Europe and among Upper Paleolithic Europeans, with single cases known from Nepal and Jeju Island. Through academic studies and from an ethnic Armenian, an ethnic Kabyle, and an ethnic Han from China through commercial testing. So yeah, it's interesting that it's found so much in ancient Europe.
and Asia, right?
Yeah, Yeah, Oceania and Asia.
Okay.
So that's but this is not the main one that's in Siberia and America. C2 is that one.
C3 is in America, right?
C3. Oh, okay. C2 previously known as C3. So yeah, apparently they
Oh,
changed.
so what, they changed the name again?
Oh no. Yeah, apparently so. So what I was calling C3, C2, that's the same as what you know as C3, evidently. Yeah, that's the one in Siberia and America.
Oh wow, they keep changing. That's what I'm saying. They make such a mess of this stuff. You don't know if you're going forwards or backwards or what.
Yeah. Oh well. But yeah, it's funny because I would have expected the ancient European branch of C to migrate into Siberia, not into Australia. But
Yeah. Anyway, I think you get the idea though.
sure.
Um,
But I was wondering, what's the connection historically? Like, how did you link Nimrod and C?
because well, the C of Nimrod is what got me started in all of this. Because I'm looking at the map and I'm seeing the C over here, which is Hamitic, way over here in the Middle East, Mesopotamia. And I'm saying, well, how did a Hamitic person get so much, uh, so many ancestors in Asia and the Middle East and stuff,
And not in Africa at all.
and not in Africa, and the same thing for the D. But it was the C that got me started, and I'm thinking, well, who in ancient times could this C be? And I'm thinking Nimrod. Who is Nimrod? So I go look up who is Nimrod, and I see that Cush is the father of Nimrod. And to me, that just, you know, a light bulb came on. It's
Yeah.
like,
So the only reason why you're thinking Nimrod is because he was in Mesopotamia. He's slightly closer to the east than other Hamites.
because he was the king of the world, king of Shinar, king
Sure.
of Sumeria, king of the Assyrians from the beginning. And there's, when you read about Nimrod, you hear about the house of Nimrod after he was killed. That means there was a huge population with his Y chromosome.
House of Nimrod. Okay, I wasn't aware that his descendants were prominent after his death. Okay.
Yeah, because it says that they were subdued after he was killed, because supposedly he was killed by Esau, but it
Oh,
says,
that's extra biblical tradition. Yeah.
right, but it says that the house of Nimrod was subdued for a time, and then later, I guess, regrouped and went elsewhere, whatever.
Hmm.
But but there was a lot of them, and they spread all over Asia.
Okay. What do you think about the theory that the Sinites coming from Canaan has something to do with the early Chinese?
The
I hear that one.
Sinites, what?
Yeah,
Who's the Sinites? Who are they descended from?
Canaan. That's one of the Canaanite tribes. They're connected with the Sinai Peninsula, but that their name also sounds a lot like
Sinai.
Sinai, as in China. Yeah.
Um, they would have. So where, you mean that might be C, is what you're thinking?
Well, it's been suggested. I was thinking D
Yeah,
because you find uh, you find that a lot in the Negrito populations, and before the O Chinese that we have today, before they came along, there were small dark skinned people in China, and I'm thinking that's the same people. You don't find D much at all in the main part of China, populous China today. But you wouldn't. The O people replaced them, and look where D is now. It's on the periphery of China. So I'm just wondering.
yeah. Well, I named the D Havala because of its location. It
Hmm.
goes right up through Burma, up into Mongolia. You have the D. Paleo-Siberian, D,
Quite a bit
and
in Japan too.
Jomon all the way to Japan. So I named it Havala for the time being, just to give it a name. But
So
you're
D,
thinking the Sinos might be
that was an early idea I had, but because of the way the genetic structure is, like I said before, I kind of gave up all this, and I'm thinking now it's like maybe there's a high association between Havilah or between the Sinites or whoever you want to call them, but there's a high association between this Hemitic group and Haplogroup D. But we can't necessarily say for certain, yeah, D comes from this one guy. But we can say that his tribe ended up with a lot of Haplogroup D. And that's kind of how I'm looking at it at this point. Is you can always say, yeah, there's this very powerful link between a certain patriarch and a certain haplogroup, but you can't necessarily say that haplogroup came from that guy. You just have to say his tribe is associated with this haplogroup, because you're never gonna find a tribe that's 100% one haplogroup. So you don't know, is the biggest haplogroup in this tribe from their nominal ancestor? Maybe, maybe not.
here's another link between G and C right here, because today the biggest population of G is in this area here and in this area here,
Yeah.
and it's associated with the C of Nimrod as well.
Mm-hmm.
So if that's, I mean, I guess it could be a descendant of another descendant of Ham, because I mean, Cush had lots of descendants. I mean, but it's not even. It's totally separate from Cush, though. It's totally
Yeah,
separate from the A, B, C, D, and E.
it is. And I thought it was kind of strange that you seem to have A, B, C, D, E that differentiates later in time. It's just one for a while. You've got F, G, H. They're all in Asia, and then you've got what becomes A, B, C, D, E. It's this one lineage that's in Africa. That doesn't seem right. So probably what happened, if this is correct, then probably the way it got that way is you had the ABCE lineage that diversified later on, and it kind of replaced whatever lineages were there before.
But there is a mistake here. See this E3B1V12 and E3B1V32. This is the same lineage of Mitzrayim, and they have it Cushite. So that's a mistake.
Well, Cushitic right there refers to a language family, and it's funny because that language family is part of a bigger family that also includes Semitic. So what they're saying is one language family led to Semitic and Cushitic, which can't be correct. So I think the name's just not a very good name.
So what we have this is one tree here. It's separate from this tree here, but this V12 includes V13, which is in Europe, and the V32, which is down here. It's the same tree. But then there's another tree outside of Africa of Canaan, which is like Z830 or something, but it's a total complete tree, totally outside of Africa, and it's in Saudi Arabia, Anatolia, and of course through Europe, southern Europe.
Hmm.
But it's totally separate from Mitzrayim and Put.
So are you saying that's another branch of E?
Yeah, that's another branch of E, another tree, another distinct tree of E. Yeah.
It's weird because E for a very long time was just E, and it branched off into E1 and E2 and all the rest. Apparently, late in history, E and D were one for a long time. After AB split off, D and E were one, and then finally D and E split, and then finally E split into E1 and E2. That's certainly the way the DNA tree reads.
Yeah,
If you got
because
everything
I mean
right.
it seems backwards to me that there's so many people that are E3. Seems
Well,
totally backwards because this Berber Put is E3, Mitzrayim is E3, and I think Canaan is E3 too.
that's weird. This map may be kind of old. I'm not sure they even call anything E3 anymore. They may have changed
Probably,
that too, but there's some E branch. Uh, the
yeah.
names tend to get really long and weird. I know in Jeanson's book you've got E1B1B. That's really common in North Africa. That may be the same thing. But as for Put, I have a crazy theory about Put. If you want to hear it,
Yeah.
I'm thinking Put might actually be the Khoisan people of Southern Africa, which sounds crazy because there's no connection between Put and
Well,
Southern Africa.
yeah.
But
It's kind of weird the way they have it. I'm trying to find a map here to show this, but what am I doing here? Oh,
most historians connected Put with North Africa. A lot of people today connect the ancient land of Put or Punt with East Africa. You know, uh, Ethiopia, Somalia area. And what's interesting is the Khoisan people, or what physical anthropologists will call Capoid racial type, they apparently used to live in East Africa, where the ancient land of Punt was supposed to be. The Egyptians traded with Punt a lot, and so there's also a possibility. A lot of anthropologists don't like this anymore, but it used to be really common that they would say the original inhabitants of North Africa were Capoid, or they were like the Khoisan people. So I was thinking, well, if Put was the first person to move to North Africa, Libya area, then he's probably the Khoisan, and they got pushed into Southern Africa eventually. And they have a very unique language group, would be a separate language at the Tower of Babel, not related to Shem's languages. The Berber languages are related to Shem's languages, and those people, they have a Hamitic Y chromosome, yes, but they're autosomally and in terms of mitochondrial DNA, they are like Shem's people. So there was a takeover at some point, and this is pre-Islamic conquest. You had Caucasian-looking people in North Africa for a very long time, and I'm thinking that's mostly Shem.
um, okay. So this probably doesn't show. What is this? Mitochondria? What is this stuff?
I
See,
don't know. Everything is M.
yeah, it's 170. That's me right there. But 35, that's one group. Yeah, this is confusing.
What's M170?
170 is me.
What do you mean?
I'm an I M253, which comes from 170.
Okay. I'm in haplogroup I myself, actually. So we're cousins.
Okay. Are you an M253?
I don't know. I don't I don't know all the details on that.
All right. So 35, 96.
Now I'm what they call I1, which is the typical in Scandinavia.
Yeah.
That's probably the
And
same thing.
my answer, I can trace my family, my surname back to Edinburgh, Scotland.
Hmm. Well, mine's German, so that still makes sense.
Yeah. Let's see.
So
Yes.
what are all the M's on this map?
I this is one group. M35 is one group. That might be the Canaanite. Yeah, it's hard to say. Then there's this. I don't know what this is. I can't I can't control this very well. Guess I have to copy it. But it's not a very clear map. The other day I found on my phone I could find a whole bunch of them. That made
Yeah, that's
sense.
fun again.
Okay, this is the same thing.
I'm not used to seeing this kind of label though.
Yeah, me neither. I mean, I do see it. I mean, I know what there's M170. There's M172, which is J2. M35 is like African or something.
So these are markers. Maybe M stands for marker.
Yeah, it would have to be some kind of sim. Here's M70 172. That's Judaic. That's Judaic right there. Now I don't know why they have it like this, but this one of these is Canaan. This might be this M35. This is M2. Might I guess might be good. I don't know. M91. Yeah, this is kind of hard. Kind of hard to control here. Hold on.
And of course, they've got the origin in Africa there. You know.
Yeah, and there's the C, and I don't know if they have the D.
Well, I see two lines going through Arabia, going through India, down there where your mouse is. There's two lines, so it's probably C and D.
Yeah.
I guess.
Yeah, probably. Oh, and then the C goes all the way to America. And this has going through. Oh, it's
that looks like D. That lower one.
This is D. Yeah, this would be D probably. Anyways, I got to get some more maps together.
This stuff's constantly changing. I'm definitely looking forward to.
Well, that's the thing.
They get a little more figured out.
They relabel it, and then you don't understand anything what's going on.
Yeah. That looks mitochondrial.
Okay. Yeah, that's mitochondria. Did you notice how they have they label it A, B, C, and D in America, but the A and the B are Semitic, and the C and D is Japhetic or Asiatic.
Yeah.
You got the A, and then you got the X here too. This X in this area is the copper mines.
Yeah, that was. I heard you say that was really interesting because I'd heard of small amounts of X in the Americas, but I didn't know about that association.
And it's in the same area where the R1B is too.
Yes, that's pretty interesting. Definitely seems transatlantic, doesn't it?
And they don't tell you where the T is. They don't even tell you where the T is in America.
I saw you were pointing that out on that one diagram in the video, and I was really surprised. I've never heard of T in Native Americans. So I'm wondering, do we know for sure, is that Native Americans or is that
it's supposed it's supposed to be Native Americans, but the Native Americans do come back as Mediterranean quite often.
Yeah, I've heard that.
And they're wondering how do they get Mediterranean? Here's the Y. The Y split from A. See that?
Mm-hmm. Yeah, I don't know all the details of the mitochondrial DNA as well. I don't know what's related to what as much.
Yeah,
but it sounded like we were in good agreement on, at least on who's Shem, Ham, and Japheth and where to put the root. It sounded like we agreed on that.
Yeah.
It's just interesting when you find that other people have reached the same conclusions.
Well, I was shocked that Jensen came to a totally different conclusion.
He was
He
coming
had,
from a totally different place, and his identification of Shem was based entirely on the Jews being LT. And like I said, I was talking to Dr. Carter. You saw the exchange there, and he's saying, yeah, the timeline thing doesn't necessarily work. That's the only thing that connects Abraham to LT. There's nothing else.
yeah,
I think we can
because
kind of ignore
LT,
that part. I love what Jensen's doing in some respects, but that part I'm gonna ignore that. That's not any good, as far as I can tell.
yeah. Now it's crazy. These search engines are totally different too. It's hard to go back and find what you're looking for sometimes.
Yeah.
Because I found some ones in Africa, exclusively in Africa, uh, that were pretty clear.
Now there is some branch of D that's in Africa,
So yeah,
and I feel like there could be a pretty good association the between what was I saying, between the Sinites, the eastern group of Canaanites. There could be a pretty good association between that and D,
yeah.
possibly C, but I don't
Except
know.
they would have to belong to the tree of the Canaanites, and if they don't belong to the tree of the Canaanites, then it would probably be the
Yeah,
Sinai.
yeah. So that's the thing. The tree doesn't seem to agree well with Genesis 10. So I'm thinking the reason is the tree from Genesis 10 is mostly covered up by the DNA tree, um, where you just got a couple of Noah's grandsons that their Y chromosomes are dominating today, and no one's found most of them. Most of them are hidden. So there might be an association between D and the Canaanites, but that doesn't mean that Canaan himself had haplogroup D. Doesn't mean that at all. I'm pretty sure he did not, because I don't think it existed yet.
Yeah. Now this is probably not showing anything we're looking for. It's just probably tribal and language. Oh, well, yeah, it's rough to be looking for the stuff that you're looking for, right?
Yeah. Oh yeah, I've seen that one. That's oh yeah yeah that's
This is
mitochondria.
a mitochondria. Yeah. Well, let's see here. The X splits off from the Y. The X goes into the area of Madai, where Madai was, and of course Madai is in the area of the A. If if the Q is Madai.
That was another thing. Did were you just following Q when you connected Madai to those places, or was there a historical reason why Madai would be there?
Well, because Q is in this area of the Caspian Sea right here,
A little bit.
and it's in Europe where it's supposed to be because Madai was in Europe,
That part.
and
How do we know that?
because they that's one of the historical references is that Madai settled in Europe, which is I can't give you a reference right now, but I was watching one of Standing for Truth or Mattman's video. Um, he said that Madai was in Europe, and then I'm thinking, well, that doesn't make sense. But then I looked, and the Q is in Europe.
Okay. Well, I don't know, because I had never heard of Madai being in Europe or the Americas. Of course,
Well,
everyone's heard of Madai being the Medes, and
the
presumably
Medes, right,
the other Indo-Iranian people
right.
too.
They're the Medes, exactly. They're the Medes, but the Medes went up into Europe, into this area,
Hmm.
which
Okay, that's
was strange to me. It was also strange to me that there was a Q up in Europe, and I'm thinking, oh, that matches where Madai was, exactly. And plus the X and the W. The W is another branch, or Semitic branch, the W and the I.
Yeah. So my first exposure to all this years ago was Paul James Griffith. Have you heard that name?
No.
He's not really prominent, but there was a video called Tracing Your Ancestors Back to Genesis. It was this hour-long presentation, and um, he had, I don't remember him connecting Madai to Europe, but he did have a lot of Shem's descendants that he believed he could trace to Europe. And that was interesting to me. And I more recently thought, what if Shem mixed in with a lot of Shem's descendants, mixed in with Madai's descendants, and they went into Europe. And a lot of the European nations have traditions that they came from the Scythians. Well, the Scythians are this big, what's a Scythian? It's basically when the Greeks said Scythians, they meant anyone out there in Central Asia. So it's this huge mix of people,
It
and
was a mix, yeah.
there are all these historical references to, oh yeah, these people left the Middle East and became counted among the Scythians. So it's like it could be anyone. So I was just thinking, it seemed like Madai, who Scythians are traditionally considered Indo-Iranian, like the Medes. So Madai and probably a bunch of Shem's descendants got mixed up out there and ended up in Europe, and that's probably the Indo-Europeans, probably how they first got to Europe. That's what I'm thinking.
Yeah, and then there was Nimrod and the Assyrians went into Europe too.
So you've got the CGK stuff happening up there, and then after that you get I, and I'm thinking I is probably the Indo-European speakers. A lot of Shem's descendants mixed in with Madai's people come up into Europe, and later than that you get R1A, R1B. That's what seems to be happening, I think.
yeah, this one here is interesting, but I can't. Again, it's got these numbers. You can't even understand what it is.
Yeah, what's up with the numbers all of a sudden? I'm not used to seeing these.
Yeah, I mean it's terrible. You can't even tell who's who or what's what. At 35, it's so you don't know what it's talking about.
I
It
mean,
could be empty DNA for all I know.
it looks like the same shape that I'm used to seeing, because it looks like on the left that looks like Ham, and then you got IJ right there, yeah, and then on the
Oh,
right,
IJ. Oh, okay.
and
That's why it's so confusing because it makes no sense to me.
I'm just guessing here. That's what it looks like, but yeah, the labels are pretty strange. That looks
Yeah.
like
Okay.
IJ in the middle, and then Japheth on the right.
Yeah, I hate it when they don't use the. I mean, they don't all. I mean, all the labeling is all different.
Apparently,
And then you go to do a search, the searches are all different. You can't even find what you're looking for. Anyway, there's one here. I don't know if this will help. Okay.
hmm.
It's a Bantu. These are just tribes, right?
Yeah, language families.
Okay. See, that's the thing. You can't even go by language. It doesn't follow the DNA.
Jeanson had several slides, or he calls them color plates. Yeah, color plates in his book, that where he compared language families to haplogroups, and it was pretty interesting how some of them seem to line up really well. But you can't necessarily say, oh, the guy who had this haplogroup first, the first person to have this SNP that led to this haplogroup, he was given this language at Babel. You can't say that because you don't know. History's messy. don't know what happened between then and now.
Yeah.
But there could be a high correlation between a tribe and a language and a haplogroup, and that can be useful for tracing people around the world.
This is too bad. I gotta try to find the. I gotta try to find the stuff. Oops, where am I? Anyways, it's probably pretty boring.
Well, it's been
But,
interesting.
and I don't want to take up all your time. You might have something to do or something.
Well, thanks for the conversation. That was interesting.
Yeah. Yeah. Well, we got something to work on, anyways.
A lot of people have something to work on. It sounds like there's
Yeah.
a lot to be done.
All right. Thanks for your time, Ryan.
Yeah, you too.
And God bless.
You too.
All right.